Good morning, my name is Richard Evans, Regional Sales Manager for Foster+Freeman Limited. Welcome today to our Arson Investigation Techniques webinar. Before we begin, a little bit of housekeeping as usual. All guests are muted during the webinar, but at the end of the webinar, when we go into our question and answer session, please feel free to ask any questions during using the chat box on the side of your screen, and any questions asked we will try to answer in the time allowed. If we don't manage to answer all the questions, please also feel free to email us at sales@fosterfreeman.com and we'll do our very best to answer any questions that you may have. So, Arson Investigation Techniques, detecting and examining evidence following a fire. Now, arson in the UK remains one of the largest single causes of fire in England and Wales, accounting for almost 50% of all fires attended by fire crews. In the years 2017-2018, fire crews in the UK attended 167,000 fires in England, and of those, over 80,000 fires were started deliberately and resulted in over 160 deaths. The National Fire Chiefs Council has estimated that arson in the UK costs the economy as much as £11 billion annually. The loss of life, paired with the huge economic cost of arson, has made the reduction of arson as an important strategic interest. Now, obviously, in order to reduce cases of arson, early intervention must take place to prevent the fires being started in the first place. However, not all and every fire can be prevented, so it's important that when a deliberate fire does occur, we're able to successfully identify and prosecute the perpetrators, creating a strong future deterrent. Investigating cases of arson is fraught with difficulty. Fires are destructive, spreading and consuming evidence as they grow. In fact, many fires are started with the intention of destroying evidence. Even the process of putting out the fires using huge quantities of waters or chemicals can further reduce the chances of locating useful evidence. But despite this, valuable evidence can still be retrieved. Upon entering the fire scene, an investigator may typically search using a powerful white light. Using a tool such as a Crimelight Auto, the investigator would be able to conduct the search across multiple wavelengths, whilst recording the entire process at the same time. Items of evidence detected at a fire scene may include incendiary devices, such as cigarette lighters, for example, or matches, the presence of ignitable liquids, such as gasoline or petrol, indications of forced entry into the property, trace evidence left behind such as hairs, fibres, fingerprints, blood or other bodily fluids. Evidence of crimes in addition to the possible arson, such as weapons or bodies, drugs and or clandestine drug laboratories equipment may also be found. So let's start by looking at items that may have been used to start a fire, such as incendiary devices such as lighters or matches, or ignitable liquids such as petrol, paraffin or other combustibles. Splashes of petrol or lighter fluid or another form of liquid accelerant on suspects' clothes could prove to be valuable collaborating evidence, trying to match the perpetrator to the scene of the crime. And while many common liquid accelerants are clear and practically invisible when soaked into fabric, we can often use a crime light to reveal what the eye cannot see.
I'm Dave Skaisbrook. I've been a forensic scientist for over 40 years. I initially trained with the Metropolitan Police Forensic Science Laboratory, then worked for the Home Office Forensic Science Service, and I'm now employed by my own company as a freelance consultant with S&T Forensics. With scene going, it's important to visualise physical evidence, because without visualising the evidence, it's not possible to claim items, to retrieve them, and to take them back to the laboratory for further examination. Particularly at fire scenes, evidence can be obscured by smoke staining or by heat deformation. So visualising the evidence is particularly important. For example, we can see blood staining through light sooting using a Crimelight, and by then recovering that blood, we can go on to do DNA profiling. In relation to fire accelerants, ignitable liquids, we can use it in some circumstances to look for those accelerants on the suspect's clothing, thereby not only locating the flammable liquids, but also a way of visualising the distribution of that liquid on his or her clothing.
In our study into the visualisation of accelerants, we've used the Crimelight Auto to detect and image the evidence. Using an all-in-one device such as the Crimelight Auto, an examiner could perform an examination at the scene, capturing and recording images as they go. The same examination could equally be achieved in the lab using either handheld Crimelight sources or a specific light source designed for the laboratory, such as the Crimelight 8x4, with subsequent imaging and enhancement carried out by the DCS5 workstation.
Or at the suspect's house, the crime scene examiner is looking for clothing to retrieve that might have accelerants on to implicate the suspect in the arson. So we're starting our examination with the white light. The scenes of crime officers at the crime scene examining items of clothing from the suspect for potential accelerants. And we can use a variety of lights, but if we choose the blue light, we have the automatic filter selection. We can quickly locate the accelerant used and accidentally spilt on the suspect's clothing. We're using the 3-burst option that's now available with the Crimelight Auto to take 3 photographs in sequence, and from these we can take a nice sharp image. By looking at the gallery, the best image can be selected and sent to the laboratory via wireless connection. Oh, very nice image with the weave of the fabric, very clear. And this image can be shared with the senior investigating officers ahead of the scenes of crime officer getting back from the scene via the wireless application available now. We've got a number of functions where we can invert the image or grayscale, sharpen the image, rotate or crop or annotate. All these functions are available with the new Crimelight Auto. So we've got the shirt that we've retrieved from the suspect's home, and we're looking for potential evidence types. We can choose a number of different lights. Common lights used for accelerants will be blue, blue, green, green. So if we look at the green, we've got a nice image here of potential accelerants. We can capture this image. We can also try the blue-green, and we can capture this image and the blue. It's always nice also to have an image in the white light, so you can locate the stain when you've not got the lights on. Capture that image. These can all be viewed in the gallery, and it's possible to look at the images and compare them in the comparison. And we can have two images compared side by side, or we can now have this facility of 4 images with the different light sources. So we've got the white, the blue-green and the green all imaged together, and we can store this combined image, and we can use this in our report when we review the item. So here we've got another item of clothing we're examining, and we're going to again use the different light sources, and we can see the green is not such a good light source for showing accelerants on this particular item of clothing. But if we go to blue-green, also not visible, but in this particular case, this fabric clearly shows the accelerants in the blue light. Not as clear as the other fabric, but all the fabrics are different, and that's why we need to use the different light sources to examine the items. We can capture the image and we can compare it to our white light. Okay, and use this in our report later.
Detecting fingerprints following a fire can be a particularly difficult task. In most cases, when we're looking for fingerprints, perhaps staining or applying powder to a mark, we're attempting to visualize the physical presence of fingerprint deposits made up of sweat or natural skin oils. But in the case of fire, the fingerprint will likely, unless protected by a layer of soot for example, most likely be burned away by the intense heat of the flames. Using our Recover LFT system, it may still be possible to visualize fingerprints on metallic items even after all the physical deposits have been destroyed. This would be especially true on metallic items. The unique chemical process of Recover actually develops fingerprints on the deposit sites where fingerprints previously resided. A chemical reaction between the fingerprint and the meta causes near invisible corrosion to occur on the metallic surfaces. The Recover chemical and process adheres to this abrasion to show ridge detail. Earlier this week we had some fun testing out just how effective this process can be.
Okay, here we have our LFT Recover instrument. We can use this on metal types which have been exposed to extreme conditions, such as heat, as we have seen with our evidence. We fix the chamber in place, then we take the chemical, place inside the chamber, and then with our evidence fitted onto the evidence rack, we will lower it gently into the chamber. Next, on the software, we will move into the software controls. You can choose whether you are going to process copper-based or silver-coloured metals, whether you're using a small or a large chamber, and then the instrument is ready. So now we will put the lid onto the column, and using the lid control, we will bring it down on top of the chamber. We'll then press start. Now the instrument is ready to fume, so we simply press the go button. Okay, so we have our DCS5 imaging system, and we're going to take some of our samples that we've just treated in Recover and analyse them for finger marks. First, we have the lighter, and what we're going to use is actually a mix of different techniques across our range of evidence. First, on the lighter, we're going to try and use the reflective UV process. So, for many of you who are already aware of this process, and for others who don't, what we simply use is a special quartz lens. We use a special bandpass filter on the end of the lens, and then we use an 82S Crimelight. Now, what's really important about reflective UV is often the angle of light, and as we move around the evidence, we can start to see a number of finger marks becoming illuminated. What we'll do is we'll quickly take a preview. And if we zoom in, we can start to see the presence of multiple finger marks across the surface. We change to grayscale. We can see some finger marks, including a partial print along the bottom, even containing some third level detail. So our next sample is a small brass type hinge, and this time what we're going to do is we're going to use coaxial illumination, and we use this on the DCS5 for when you have shiny or reflective surfaces, so items like metal items. We can use coaxial illumination to actually remove the reflections and the glare and allow us to visualise the finger mark. So in this example, we can actually see a finger mark visible. It is only a partial finger mark, but due to the size of the object, this wouldn't be unexpected. We can zoom in, and we can see clear ridge detail along the middle of the sample. Okay, so on the final sample we're going to show you, we have the brass lighting ring. What we're going to do with this is, because this is quite a difficult shaped object as well, we're going to use dark field illumination. Okay, so we have our dark field ring light. But one of the really nice things about the DCS is we use a modified camera. So we've modified it so we can allow infrared through. We use the dark field around the sides, so we're giving illumination from the sides. And we can start to see finger marks becoming visible. So we're going to move the dark field up and down around where our finger mark is situated, so we can get the best illumination. We can take a preview. Then change to grayscale, and there is one of our finger marks. If we actually move the brass lighting around, so we'll go back into live view mode, we can actually see another fingerprint a bit further along, and we can even see the core in the centre of the finger mark here. We'll just adjust our light. Take another preview. And there we have our second finger mark. Okay, so what we've done now is we've actually just reversed the light fitting, so we're now looking at the opposing side. Still using dark field illumination with infrared light from our FLS. We can very clearly see a lot of ridge detail now coming into focus. So we'll take a quick preview. For grayscaling, we can see our ridges here, along here. We then also go back into live mode and we rotate our fitting around to search for other finger marks. We can now very clearly see on the other side we have multiple fingerprints becoming visible. Take a preview. And then finally grayscale and invert, and here we have a finger mark here and a finger mark here.
While some of the marks that were found in the demonstration were clearly visible to the naked eye after being fumed with Recover, we would always recommend using the best available imaging system. This would include imaging in the infrared and UV if those sort of imaging systems are available. In all cases, the marks were only faintly visible or perhaps not visible at all, and a suitable imaging system such as the DCS-5 with the associated lighting is capable of revealing fingerprints of incredible quality, making it quite possibly the most important single piece of equipment in the fingerprint examiner's arsenal. So as you've seen, using a combination of Crimelight forensic light sources to detect hidden evidence and the Recover system to reveal impossible fingerprints, we can go a long way towards discovering the cause of a fire, perhaps also through the detection of accelerants. We may even be able to identify the person responsible for starting the fire through the detection of their fingerprints at the crime scene. In either case, the use of modern forensic technology is essential. So, now we'd like to go into our question and answer sessions. Please put any questions into the text box and we'll be happy to try and answer them. Thank you.